My name is Max Cataldie, and this is a video on boiler feedwater systems with deaerators for ME 4933. Boilers play an essential role in many manufacturing facilities. They are used to produce steam for various process needs. Water must be purified before entering a boiler. An effective boiler feedwater system makes this possible. Facilities that implement an effective boiler feedwater system will have a reduction in boiler failure and will maximize steam generation. The goal of a boiler feedwater system is to remove impurities from natural water sources so that it may be used in boilers. A facility may produce steam with water that comes from lakes, rivers, and streams. This water contains suspended matter. A clarifier is used to remove the suspended matter from the water. Next, an ion exchange process called demineralization will remove dissolved salts from the water. After demineralization, a deaerator will remove dissolved gases from the water. The main goal here is to remove the oxygen that's dissolved in the water. Finally, a centrifugal pump is used to pump the water from the deaerator to the boiler. A schematic of a clarifier is shown to the right. The purpose of the clarifier is to remove suspended matter from the water. The first step in this process is coagulation. Coagulants such as lime, sodium aluminate, and aluminum sulfate are added to the clarifier where they react with suspended matter in the water to form a precipitate. A density differential then causes the sediments to accumulate at the bottom of the clarifier. A scraping mechanism then removes the sediments from the bottom. The water is then filtered. Cold water filtration systems will use pressure-type sand filters, while hot water filtration systems will use less soluble material such as magnetite for the filtration medium in order to avoid the formation of calcium silicate. Calcium silicate formation may result in a scale buildup inside of the boiler. After the clarifier, the water is sent to a series of one or more cation and anion exchange units. The exchange units allow for the demineralization of the water. Demineralization is an ion exchange process aimed at obtaining water that is practically free of dissolved salts. Only minerals that can ionize in water will be removed by demineralization. The first step is for the water from the clarifier to enter through the top of the exchange unit, where it then comes into contact with a graded anthracite bed. Anthracite is used due to its ability to bind with minerals in the water. Anthracite is another word for coal. Over time, the exchange unit will become full of minerals. For this reason, a cleaning process is employed. First, water enters through the bottom of the exchange unit, where the water will fill the tank and will come out through the top. After cleaning the exchange unit with water, chemicals are used. The chemicals used to clean the exchange units are called regenerates. The regenerate used in the cation unit is sulfuric acid, while caustic soda is used in the anion unit. This is the only difference between the cation and anion exchange units. Sulfuric acid will be effective at removing certain minerals inside of the exchange unit, while caustic soda will be effective at removing different minerals inside of the exchange unit. That's why both cation and anion exchange units are needed in the demineralization system. Reverse osmosis often occurs after the cation and anion exchangers to allow for additional filtration. This process forces water through a membrane that will trap minerals and allow only filtered water to pass through. The membrane filter should be backflushed periodically in order to avoid the excess buildup of minerals on the filter. Silica is one of the main minerals removed during demineralization. Silica has the potential to create a hard scale inside of the tubes of the boiler, and it vaporizes with the steam leaving the boiler. This silica has the potential to create problems later on in the manufacturing process. The water leaving the demineralization system contains dissolved oxygen that is highly corrosive to the tubes of the boiler and the pipe connecting the boiler to the deaerator. Deaerators are used to remove this highly corrosive oxygen before it enters the boiler. The three main types of deaerators are tray type, spray type, and vacuum type. Tray type deaeration begins with the water from the demineralization system entering the deaerator, while simultaneously low pressure steam enters the deaerator. They meet at the trade section shown here. The tray configuration is used to allow the water to have sufficient time to come into contact with the steam. The steam forces the oxygen in the water to the surface, where it is vented off at the top of the deaerator. The deaerated water is stored in the tank shown here, where it is then ready to be pumped to the boiler. Spray type deaeration is a little bit different than tray type deaeration. With spray type deaeration, water enters the top of the deaerator where there is a spray nozzle attached. The sprayed water is heated with steam to its saturation temperature by the steam sparger. The steam sparger is a device used to spray steam directly into liquids. The water that has been heated by the steam sparger flows over the dividing baffle into the deaeration section. At the deaeration section, a high velocity steam scrubs away the dissolved gases in the water. The dissolved gases in the water are vented off through the top of the deaerator. The water is then ready to be pumped to the boiler through at the bottom section of the deaerator. Vacuum deaeration is very similar to tray deaeration. The main difference is that a vacuum pump is used instead of an air vent. The steam rises from the bottom of the deaerator as water enters through the top. Contact between the steam and water allows the dissolved gases in the water to escape. This separation of dissolved gases occurs at the trade section. The vacuum pump creates a vacuum that allows the separated gases to leave the deaerator. The deaerated water is then ready to be pumped to the boiler. Centrifugal pumps are universally used to send boiler feed water from the deaerator to the boiler. Here, it is important that the demineralization process was effective in order to avoid pressure drops in the line between the deaerator and the boiler. The pressure drops would be due to mineral deposits on the inside of the pipe. Boiler feedwater pumps have a high net positive suction head requirement. This is due to the water's high temperature leaving the deaerator. For this reason, deaerators are placed high above the boiler feedwater pump in order to provide some extra head on the suction side of the pump. Impure boiler feedwater can cause four main issues, which include corrosion, corrosion fatigue, scaling, and foaming and priming. Corrosion is one of the main issues that can plague a boiler. Corrosion can be caused by the presence of dissolved oxygen and high acid concentrations in the boiler feedwater. Ineffective deaeration is one of the main causes of corrosion in a boiler. The pH level of the boiler feedwater should be checked periodically and raised whenever it is low in order to avoid the highly destructive acid concentrations from causing corrosion in the boiler. Metals, whether that be in the boiler tubes or in the pipe connecting the deaerator to the boiler, will have a stronger tendency to corrode when stresses are applied. This is because corrosive elements can fill the cracks caused by the applied stresses and cause the metal to corrode faster and in some cases fail. This tendency is known as corrosion fatigue. Scaling is another negative effect of impure boiler feedwater. Deposits will form inside the piping and heat transfer surfaces of the boiler feedwater system when the temperature of the boiler feedwater is raised. Excessive buildup of these deposits can cause the boiler system to fail. Some of the minerals in the water include calcium, iron, magnesium, and silica. High pressure boilers are more susceptible to the effects of scaling than low pressure boilers. This is because the minerals will dissociate from the feed water at higher temperatures. Foaming and priming are negative effects that impure boiler feed water can have on a boiler system. Foaming is the buildup of foam in the boiler due to the failure of steam bubbles to break. Priming is when large amounts of water pass out of the boiler with the steam. The additional water in the steam can be detrimental to the equipment at its destination. Foaming and priming are caused by dissolved solids in the water and sudden changes in boiler capacity. Foaming and priming may be minimized through boiler blowdowns, purifying the boiler feed water, and regulation of the boiler's water levels.